Good evening, everyone. Again, there is a delay in uploading the next video. Sorry for that. Today, we are going to discuss the concept of relative velocity because it required in the course of what we are going to modify Newton's second law and linear momentum. Now look at the concept of relative velocity. Relative velocity. Here, relative velocity. We should first try to know the literal meaning of relative velocity. Relative velocity. We firstly try to understand what is velocity. However, we will take up velocity, displacement or position vector, acceleration in very detail when we will take up kinematics. Now just we are going to understand what is velocity, that is the definition of velocity. Look at now velocity. So here it is of two kinds: average velocity and instantaneous velocity. Instantaneous velocity. So, what is average velocity? V average. This comes out to be displacement over time elapsed during that displacement. So again, what is displacement? Displacement is a directed line segment from initial position to the final position. No matters which path the particle followed. Look at here. Suppose this is a path on which a particle try to move or it is moving. Say at time t1, particle is here at A. However, this is the arrow indicating the particle follows this path. If the particle is here, how one can understand here? For this, we have to take its position vector with respect to a fixed point. Generally, we take 0, 0, 0. Customary it is known as origin. So suppose here is the origin, 0, 0, 0. So this is the position vector at time t1 of the particle which is moving on this curve path. So after certain time, say at t is equal to t2, particle arrived here at point B. So what is position vector? Look at here. This is the position vector. Say this is the r1 and this is the r2. However, the particle traveled on this path. So this is the path length. But what is displacement? It is directed line segment from initial to final position. Then look at here, directed line segment from initial to final. Look at here. So this one, the directed line segment. Put your eye on this directed line. Look at from A to B. Look at this arrow. So this is the displacement. However, if we call it as delta r vector, so we may apply triangle law of vector addition. R1 plus delta r will give you, this is almost the same way, and this is in the opposite way. So this comes out to be R2. It is known as triangle law of vector addition. So here we may find delta r vector as R2 vector minus R1 vector. However, time elapsed in this displacement is, say, delta t comes out to be t2 minus t1. So in this way we are able to find average velocity. The particle comes from A and reaches to point B. It may be possible that somewhere in between A and B, particle may be at rest, may stops, no matters at all in case of average velocity, because it is average. However, in general, we may find average not about velocity of any physical quantities, but in particular case, average is not a good measure. For example, say in a class of 50 students, they appeared in the physics test. Say unfortunately, due to some or more reason, say one student got 1 mark and the others very close to 100 marks, say the test of 100 marks. And just we are going to take the average. Say average comes out to be, say, 85. But one of the students has got 1 mark. So in this regard, average is not a good measure. But if all the students got intermediate marks, say 70, 75, 80, 65, 90, like that. So if we are going to find the average, then in this types of marks obtained by the students, that's reasonable. Average is reasonable here. But in the rare case, average is not reasonable. That is why this is the average. So you may find average of anything, velocity, force, mass, volume, temperature, etc. Okay. So here average velocity is very clear, but what about instantaneous velocity? Just I am giving you brief idea about these things here. We will take up in very detail, as I told you earlier in the chapter of kinematics. But here just we are going to understand what is instantaneous velocity. Look here. This is the, say, if no subscript is written, then we understand it is instantaneous velocity. However, strictly speaking, we have to write instantaneous velocity or in the subscript inst in short. But we all know that, we all understand that if nothing has been stated as a prefix or as a subscript, then it indicates instantaneous velocity. That is why. So here, this is time rate of change of position vector. This is called instantaneous velocity, or loosely speaking, we may call it velocity at a point on the path of the particle. Loosely speaking. So I will explain. Yes, I have told you. So this is a brief idea about what is velocity. Now just we are going to understand what is relative and what is the meaning and in which way we are going to apply relative. Here relative literal meaning of relative is not absolute. It is with respect to others, but one cannot say velocity of the particle relative to acceleration. No way at all. So relative of one velocity with respect to other velocity, acceleration with respect to another acceleration, etc. So what we mean? We mean that relative means comparison. However, strictly speaking, these two not resemble, but loosely speaking, these two words resemble each other. You may take it synonymic, but strictly speaking, these two are different. So just in the loosely speaking, we take these two are same. That is why relative means comparison. So we have two ways to find the relative, or we have two ways to compare. Two ways to compare. So comparison means one quantity is less than or equal to or is greater than another. But these two quantities are of same nature or are having of same unit and dimension, otherwise not. So relative means comparison. So we have a two way to compare given two real numbers only. Yeah, real number. One cannot compare two imaginary number. However, they are of same class. Say 5 iota, 10 iota. So one cannot say 10 iota is greater than 5 iota. No way at all. In fact, one cannot say 5 plus 10 iota is greater than 1 minus iota. No way at all, because these two are complex number. Earlier, these two was imaginary number. So there is no comparison between any two imaginary number or any two complex number. Even if we take one imaginary number and another complex number, we cannot compare. Also, even if one of the number is real, other is imaginary, or one of the number is real, other is complex, no way to compare at all. So comparison is always between given two real numbers. In a similar manner, one cannot compare given two vectors. Say vector A and vector B, one cannot say that vector A is greater than vector B or is less than vector B. However, one may say that vector A is equal to vector B only when their magnitudes are same and direction or sense are identical. Direction or sense. If we think of translational, then we take of direction, and we take of rotation, then we may think of sense. However, you may take as a direction, but it is appropriate to say sense in the rotation and direction in the translation. Okay, the very concept requires very clear, that is crystal clear concept. Whatever you are studying, no matters at all. But we have to be very clear about what we are going to understand, what we are going to write, what we are going to read. Keep in mind. So here, two ways to compare. One is by taking difference. By taking difference. Say we have two real numbers A and B. Take their difference, and if it comes out to be is less than 0, then it implies A is less than B. If it comes out to be 0, then it implies that A is equal to B. And if it comes out to be is greater than 0, then it implies A is greater than B. So these numbers fall on real number line. Look at here. Real number runs from minus infinity to plus infinity. Customary, we put 0 at the middle. One may put 0 here or there, because if we put here, so it not is shorter, this is not a longer, because still we have to go up to very far, and they are also very far. So some finite section does not differ much in comparison to, that is why. So, but it looks fine if you put 0 at the middle. So, say we put a positive on the right of the 0 and negative left of the 0. So, say here the real number 5. Say here is 4. Say here is, say, 6, and so on. It is very clear that 5 is equal to 5 itself. That's okay. 5 is equal to 5. That's okay. Every person is identical to herself or himself. However, strictly speaking, their state is changes all the time. So in a dt time you may say that, but in a finite time, so itself one person, himself or herself, is not identical. However, to know these things really required metaphysics, So till that's okay. One particular person, herself or himself, identically equal. No matters at all. But right now, look at here, 5 is equal to 5, okay? But any number which falls before 5 or less than 5, or you may say that 5 is greater than all those numbers which fall left of 5, and 5 is less than all those numbers which falls right of 5. If numbers are given, that's okay. Then we may draw a number line and we may compare. But here, if number is not given in terms of arbitrary constant, so we may think like that. Now, another way to compare is that by taking ratio. However, still the concept of ratio always in the same nature of the quantities. So one cannot compare magnitude of velocity, or we may not able to take the ratio of magnitude of velocity to the magnitude of acceleration. No way at all. So we may take ratio velocity of one particle by taking its magnitude to the magnitude of the another particle in terms of velocity, not in terms of any other acceleration or force or linear momentum, etc. So that is why same unit and dimension. So here is the two real numbers again. We have a and b. So firstly we have to take it modulus and then compare by taking ratio. But in fact it is very clear a and b are having of same unit and dimension. However, one thing I would like to mention also here, if one of the real number here a and b, or you may call it modulus of a or modulus of b, is 0, still we compare, but we put 0 in the numerator, not in the denominator, because any defined quantity is divided by 0 makes the function undefined or not defined. That is why. So one cannot say 0 by 0 is equal to 1. However, 0 in the numerator is allowed, but 0 in the denominator is not allowed, which makes the function not defined. That is why. However, I provided the explanation in earlier lecture. You may go through earlier lectures, you may find how any defined quantity by 0, even 0 by 0 is not defined. So it is clear, non-zero numbers a and b. Non-zero numbers a and b. So after taking its modulus, here modulus of vector a over modulus of vector b, if it comes to be is less than 1, then it implies that modulus of a is less than modulus of b. If it is equal to 1, then it implies that modulus of a is equal to modulus of b, and if it comes out to be is greater than 1, then it implies modulus of a is greater than modulus of b. However, in practical life too, we have a concept of relative. Concept of relative. Look at how. Say two friends x and y. Friend x and friend y. Say friend x has $2, however American dollar, and the friend y, these two are friends, that is why I am called like that, has rupees 150. and we want to compare. That is, which one has more than the other. But we are not in a position to compare. Why? Because their unit are not same. However, they are different currency. The American dollar, and it is my country, India, rupees. This is the symbol. It's also a symbol of American dollar. So either we have to convert currency dollar into currency rupees, or vice versa. So more or less, we are not going to indulge in that. Say 1 American dollar right now, say, is equivalent to rupees 75. Rupees 75. So it has got, after conversion into rupees, say my country Indian currency rupees, this comes out to be rupees, say 150, and this is also rupees 150. So we have to two way to compare, by taking difference or by taking ratio. These are the positive numbers. You may follow any one of these two paths, say by taking difference. So rupees 50, 150 in fact, minus rupees 150, this comes out to be 0. This implies that X has rupees 0 with respect to Y. With respect to Y. In return, Y has rupees 0 with respect to X, because still they have same rupees 150 after converting dollar into rupees. However, if a friend X has $1 and still it has rupees 150, then somehow you may construct yourself. Just it is an example to you. You may think like that a lot. Now it is very clear that relative word is very clear, and velocity is also somehow, by definition, it is very clear. So one question is that the relative velocity is more pronounced in physics. However, the article like relative velocity, but relative you may apply in any physical quantity. However, in your day-to-day life as well, look at here, these are the currency and rupees in terms of dollar. You may use in day-to-day life. So one can say that Mr. X is more intelligent than the Mr. Y and vice versa. So there is also a comparison. There is always a concept of relative is there everywhere. So here relative velocity, you may find any text of physics, relative velocity, but seldom you may find relative acceleration, relative force, relative momentum, but we are doing very frequently. But we are not speaking or not find relative acceleration article, relative linear momentum article, or like that. So that is why we confined here for relative velocity. So here now, so just I am trying to give you the concept, whatever I am discussing in a great detail. So you are able to understand by carefully watching the video Still, if you have any query, then put your query in the box, comment box. Then I will try my best to explain that. Okay, so we are going to understand here relative velocity. Relative velocity. Now we have seen what we do once we find relative. However, by taking their difference. So, we may explain or we may think, say, velocity of particle 1 with respect to particle 2. Velocity of particle 1 with respect to particle 2. So, as by the taking difference here, v1 minus v2. But I do say plus of minus v2 means we nullify the effect of particle 2 or the velocity of particle 2 that provide you the relative velocity of 1 with respect to 2. We may take not as a difference, but we have to nullify the velocity of particle 2, then it will provide us relative velocity of 1 with respect to 2. So, this is the case here, v1, but one thing we must know is this result we always hold good, or what are the conditions required for this relative velocity, like that. However, the condition for this relation holds to be good is not explicitly explained in any text, whatever you have. So, be careful here, be serious here. This result hold good if and only if, number 1, magnitude of velocity of particle 1 and particle 2 are measured with respect to same frame of reference. Mod v1, mod v2 are measured with respect to same frame of reference. Same frame of reference. Number 2, modulus of velocity of particle 1 and modulus of velocity of particle 2 are very less than speed of light. That is c is equal to 299,792,458 meter per second. However, if we round it here, so approximately it comes out to be 3 into 10 to the power of 8 meter per second. So here, but this condition must require, but this condition mod v1 mod v2 are very less than the speed of light, then you may use this result. If this mod v1 and mod v2 are comparable to the speed of light, say 0.5c, 0.6c, 0.7c, 0.8c, etc. One cannot take c or greater than c as per Einstein. As per Einstein. Because c is known as Einstein limit. So, any particle cannot attain the speed which is equal to the speed of light or even not greater than the speed of light, but 0.6c, 0.7c, 0.8c, etc. may achieve, however seldom. So, if the speed is 10 meter per second, 20 meter per second, 50, 100, 1000 meter per second, then you may use this result because these speeds are not comparable to the speed of light. So, one cannot compare 10 to 3 into 10 to the power 8 meter per second. No way at all, cannot be. That is why. So, this second criteria must be fulfilled here. If speed is comparable to the speed of light, then we have to use relativistic velocity transformation. However, it comes out to be non-relativistic velocity transformation. So, we will see separately the Galilean transformation of the velocity and the Lorentz transformation of velocity. Lorentz transformation of velocity with respect to relativistic, that is, speed is very close to or comparable to the speed of light. If speed is very less of the frame in terms of Lorentz and Galilean. So, we will see later on 10, 20, then we use Galilean transformation. But later on, but right now, here also this condition must fulfilled. And third one is medium must be same. So, if the two vehicle is moving in air, then okay. If one vehicle is moving in water, another is in the air, we cannot use this result as it is. We may use after making certain correction. For example, if a fish is moving or is swimming inside the water, however, fish is always swimming inside the water, and a bird which is swimming or flying or moving in air. So, if one can find velocity of bird with respect to fish or velocity of fish with respect to bird, and we straightforwardly use this result, then we cannot achieve the answer. So, we have to convert identical medium by the refractive index of the medium, and we will see later on one of the problem, very nice problem. So, medium must be same. Otherwise, we have to make the correction. Otherwise, we have to make correction. We have to make correction. Now, we have to study relative velocity for convenience separately in 1 dimension, in 2 dimension and in 3 dimension. Let us firstly we take relative velocity in 1 dimension. So here the concept of relative velocity, firstly we take here in 1 dimension. In 1 dimension. Say 1 dimension, say it is x axis, say a trolley one is moving towards the positive x direction with speed v1, and at certain distance away another trolley is moving with speed v2. Now suppose one person is either standing or sitting, not moving. It may move on the trolley. Still we are able to solve the problem. But if we take, it is at rest. Say this is also a person 1, trolley 1, person 1. Here, another person 2 here, trolley 2, person 2. So also sitting or standing, not moving on the trolley. However, trolleys are moving with respect to say any stationary frame. Say look at here, this is the frame, inertial frame say, and this frame is also at rest. Say frame S is it. In this frame, trolley 1, trolley 2 are moving in the positive direction of x axis, and these two trolleys, two persons are sitting respectively. So we want to know here velocity of 1 with respect to 2. This comes out to be velocity of 1 plus, we have to nullify the velocity of 2, here the minus of v2. Now we have to take the component of what here? Vector. Velocity is a vector physical quantity, so we have to take the component. So how one can find the component of a given vector? We have 3 methods to find the component of a vector. Number 1, trigonometrical method. Number 2, geometrical method. And number 3, positive axis method through a smaller angle. However, the last one we may use indirectly, but you seldom find in any text. However, trigonometrical and geometrical methods are very common and you may find in any text. So just firstly we try to know the components of vector, how one can find. So for this we take an example and one by one we try to understand how one can find the component. So look at here. So we may find components in 1 dimension, 2 dimension and 3 dimension as well. We will take up in very detail in the chapter of vector. Right now we take a vector in 2 dimension and try to understand how one can find the component of vector by these 3 methods. Look at. Suppose here is a vector. Say this angle is 30 degree. here is a vector r whose magnitude, say mod r, is equal to say 10 root 3 unit, and we try to know its component. Then firstly by trigonometrical method. So here by trigonometric, number one, by trigonometrical method. If one can try to find the component of a vector by trigonometrical method, then firstly he or she has to measure an angle made by a vector from positive direction of horizontal axis, here x axis, in anti-clockwise sense. So in this method, firstly we have to find this angle. Look at here. So how much this angle is? So you know, this is the fourth quadrant. So this angle is 60 degree. So this comes out to be 300 degree. Now very straightforward, we are able to write here Rx, the x component of vector. Here there is a twist, because in many texts you may find frequently component of a vector is a scalar or is a scalar, you may call it. But how one can say that component of a vector is a scalar? This component means parts, contributor. How the contributors of a vector is a scalar? But here is ambiguity in the concept. Component of a vector we may take as a scalar. However, it is not resembling, or it is not good component or part or contributor of a vector is a scalar. But we are saying that, like writing that, in fact teaching that. So here, if one can say vector component of a vector, then firstly we find a component and then put the unit vector of that direction of which we have been found the component. However, customary we call it a scalar. But the reality is that component of a vector is a scalar. However, it is the naive definition, naive thinking, basic thinking. However, basic cannot means wrong. But what in a school level physics we may say that yes, okay, component of vector is a scalar. However, it is not worthy, because vector component is a vector. But we may take here vector component, then we take as a vector, or if it is a component, it is a scalar. But still it is not good. Component of vector is not a scalar. Why we are calling like that? Because of the fact that due to transformation. However, transformation are of various types. Say transformation by rotation, transformation by reflection of the coordinates, and parity transformation as well. So here we take what is called transformation by rotation, or what? Rotation of the axis. Rotation of the axis. Still, we may use it in 1 dimension, 2 dimension, and as well in the 3 dimension. So still we will take in 2 dimension, but little bit later on. So if the quantity under transformation remains same, then it is a scalar. But we will find after this article, we will take up, yes, component of a vector will change under rotation. So no way to call it as a scalar. However, magnitude of a vector will not change under rotation, keeping the origin fixed and the axes are rotated, say some acute angle theta. We will find that yes, component will change. So one cannot say it is a scalar, but the magnitude of vector will not change. So it is a scalar. So this definition of a scalar is really nice definition. So in this regard, if one can say component of vector is scalar, then it is not good. Customary we are calling like that. So we will see later on. Okay. So here Rx, we may call it is a scalar, but this is the naive definition. But under rotation it is not a scalar. Component change. We will see. But right now, this is termed as modulus of vector R cos of that angle. So cos 300 degree. Here the mod R, you look at here, 10 root 3 unit. Here cos 300 we have to find. So this is the cos of 360 minus 60. So it comes out to be here 10 root 3 unit. This is in the fourth quadrant. So we will take up trigonometry in very detail in vector chapter or before or in meanwhile of vector chapter. So first quadrant, all the 6 geometrical ratios or functions are positive. In the second, sin and cosec are positive, rest 4, tan, cot, sec, cosec are negative. In a similar manner, in the third quadrant, tan, cot are positive, rest are negative. How a positive, negative we will see later on in the subsequent classes. But in the fourth quadrant, the cos and the sec are positive and the rest 4 are negative. So rest 4 are what? Sin, cosec and tan, cot are positive. Why? We will see in the subsequent classes. But here, again here, when we talk about the function of 180 degree plus minus theta and 360 degree plus minus theta, and theta may be any values, maybe 1 crore degree, 1 million, 1 trillion degree. Once we apply the formula, we have to take the angle theta is acute. Say 1 million degree, we take it any angle between 1 to 90 degree when we apply the formula. And then this again we have to use the formula and finally we will get the final answer. That's altogether different issue. So here 360 function cos cos. It means this is the cos 60 degree. So this in the fourth quadrant cos will be positive, remains that. So here 10 root 3 unit multiply cos 60 half. So comes out to be say 5 root 3 unit. Okay. Now again in a similar manner by the geometrical method, the y component, this is only we have to put the sign of that. The mod R sin 300 degree. So here this is the 10 root 3 unit sin 300, you may write like that 360 degree minus 60 degree. So here 10 root 3 unit. So the 360 or 180 degree function sin cos cot tan sec cosec cot. But in case of 19 to 70 degree function sin cos sin tan cot tan sec cosec sec. So here this is the sin 60 degree, but this angle is in the fourth quadrant. In the fourth quadrant, sin and cosec tan cot are negative. So put negative sign here on the basis of sign of these geometrical functions. So this comes to be, look at here, you can minus out here 10 root 3 unit multiply sin 60 degree root 3 by 2 to 5, root 3 through 3, and is minus 15 unit. So now we find its component by trigonometrical method. Now we are going to find the component by geometrical method. Look at how one can find by geometrical method. So answer will be same, mind you. Otherwise, these two methods not gives its support to the second methods. Otherwise, it contradicts the geometrical method. Number 2, by geometrical method. Geometrical method. So what we have to do in geometrical method? So we have to do the things in the quadrant in which the vector lies. So here this vector is in the fourth quadrant. So we have to take, say, this is the pen, this is the pointed, this the end is say black. So put it here at the arrow, and this one, say suppose the longer pen. So this is the tail. So look at here. So we have to rotate this pen in the same quadrant in which the vector lies. So rotate it the x in the same quadrant, pointing positive. So we have to put the plus sign. Here put the minus sign because it's pointing in the negative y direction. So x component, say this is the Rx. So here angle with the y-axis. So we have to take the cos here and just perpendicular sign. If we take the cos 60 degree equivalently, then the cos here, sin there. You may take any angle 60 or 30 degree, no matters at all. So take it 30 because 30 is already earlier given. So here mod r y in y cos, then in x sin 30 degree. Sin 30 degree. This is 10 root 3. Sin 30 is half. This is the 5 root 3. Look at, in the trigonometrical method also x component is 5 root 3. Now the y component. Now the y component. So here the angle with the y, so put it cos here, and it pointing in the negative because this is the point in the negative direction. Put it the minus sign before. The mod r cos 30. The minus mod r is 10 root 3. A cos 30 is root 3 by 2. Cut it here, 5 root 3 3 is the minus 15 unit. The answer will be same. Why not? Of course, because methods are different. So answer will be same. Now the third method is by positive axis method. Look at here. You may find seldom, or you may do not find in any text. Third method is positive axis method. Through a smaller angle. Through a smaller angle. So what we have to do in this method? Firstly, we have to find the angle made by the vector from positive direction of x and y axes, and then take in the x component modulus times cos of that angle, and in the y component modulus times cos of that angle. Look at here how. Firstly, we have to remove it for clarity. The question is same, no matters at all. The x and y axis, here is the vector. The angle is 30 degree, already given. So this is the r vector whose modulus is given as 10 root 3 unit. So here we have to find the angle, no matters from clockwise or anti-clockwise sense. So only from positive, the smaller angle. So this is the smaller angle. So this is the 60 degree. Because the bigger angle we have to go like that. So we have to the smaller, here the smaller angle, through a smaller angle. Positive y, this is the angle. So 90 plus 60, 150 degree. Not this, because this is a larger angle. Look at here. Again I am showing. To clarify that, here the method is through smaller angle. That is why. Now firstly we have to measure the angle. Now we have measured the angle. Now we have to write the x and y component quite comfortably. Look at here. Rx is the modulus of r. Cosine of that is the cos what? 60 degree. So here 10 root 3 unit. Cos 60 is half. This comes out to be 5 root 3 unit. Look at the answer of the earlier two method. So answer will not change. If change, then these methods contradicts each other. So no way to contradict. Then answer should be same. Now the y component, Ry is the mod r cos 150. Mod r 10 root 3. So cos 150, you write here 180 minus 30. So here is the 10 root 3 unit. 10 root 3 unit. The 180 degree function cos is cos 30. But this angle 150 in the second quadrant. And we all know that in the second quadrant only sine and cosec are positive. Remaining 4 are negative, such as cos, sec and tan cot. So put the minus sign before that and put in the bracket because it is in the second factor. So here put minus outside, 10 root 3 unit, multiply here root 3 by 2, cut it here 5. It comes out to be minus 15, comes out to be minus 15 unit. That's okay. So these are methods by which we are able to find the component of a vector. So now in the next class we will start from here. That will be very, very interesting. So wait to the next video. Really, I am glad to provide such types of explanation to you because we are not taking the class just like an offline class. So I have to ask, why sir, why not sir? You are watching from the YouTube, but still you have any ambiguity or you may have any say interesting ideas, then put into the comment box. I will see surely as my best of my knowledge, I will try to give you the answer of your comment. Okay, keep it up. Wait for the next video. Thanks.